Hello everyone. Today we will discuss a question from memory memory address mapping, memory address mapping from computer architecture. And the question that is given in the screen that the size of the memory is 4 KB and the memory is byte addressable memory that is realized using 4 1 KB memory blocks. So first of all, from this line what we find that a 4 KB memory which is byte addressable, that is to be realized using 4 1 KB memory blocks. Okay, so the size of memory that we are going to design, size of memory equals to 4 KB and the memory is byte addressable. So 4 KB means 4 into 1 K means 2 to the power 10 bytes. That is the size of the memory, and the each memory location is of byte addressable. So 4 means 2 to the power square into 2 to the power 10 bytes. So size of the memory will be 2 to the power 12 bytes. So as it is so number of bytes in this memory will be 2 to the power 12, and the location, each memory location is byte addressable, as each memory location is byte addressable. So number of memory location in this memory will be 2 to the power 12. So number of memory locations, number of addressable memory location, addressable memory locations is equals to 2 to the power 12, because the total size of the memory is 2 to the power 12 bytes, that is 2 to the power 12 into 1 byte, and as the memory is byte addressable, so each number of memory locations will be 2 to the power 12. So how many address lines will be required to address each of the memory location? As the number of memory location is 2 to the power 12, so number of address lines that will be required to address each memory locations will be 12 bits. So number of address lines to address each of the memory location will be 12 bits. Number of address lines will be, the size of the address bus will be 12 bits. Now this memory is 4 KB, which is implemented or realized using 4 1 KB memory. So there will be 4 blocks and each block size will be 1 KB. In this way the total 4 KB memory is realized. So size of each block of memory. So size of each block of memory equals to 1 KB. That means 1K bytes. So 1K means 2 to the power 10 bytes. That is the size of memory blocks, and such 4 memory blocks will be required to implement 4 KB memory in total. So number of address lines to access each of the memory location of every block will be what? So the number of addressable memory locations, number of addressable memory locations for each block for each block is equals to 2 to the power 10. So number of addressable memory locations for each block will be 2 to the power 10 because it's a byte addressable memory. So 2 to the power 10 bytes. Each byte is given a particular address. So number of addressable memory locations for each block will be 2 to the power 10. So number of address lines will be required to address each memory location for each block is how much? So number of address lines to address each location of every block will be how much? To address each location of every block of memory, will be how much? Not 10 bits. So to access each of the memory location within every block, we need a 10-bit address lines. But in total, how much in memory address lines is required for total 4 KB memory? Then there will be required 12 bits of address lines, and among this 12 bits of address lines, 10 bits will be used to access each memory location within every block. So if we just what we do this naming this 12 bits of address lines by serially from least significant bit to most significant bit. If we just arrange these 12-bit address lines starting from the least significant bit position to most significant bit position, then we are denoting the bit position. It is address line 0, then address line 1, then address line 2, then address line 3, address line 4, so address line 5, address line 6, address line 7, address line 8, address line 9, address line 10, and address line 11. These are the 12 address lines that is required in total to access each of the memory location of a memory block whose size is 4 KB. Now this 4 KB memory is implemented using 4 blocks of memory, and each block is of 2 to the 1 KB. That means among these 12 address lines, only 10 address lines will be required to access each location of every block of memory. So now we have to find out among this AD0 to AD11 which of these 10 address lines will be required to access each of the memory location of every block. So for that we go back to the question. Okay, now question is given 2 input address lines, this one 2 input address lines which is IA4, which I have denoted here is AD4. So input address line 4 and input address line 3 that are connected to the chip select port of the memory blocks through a decoder as shown in the figure. So what it is saying that among this 12 address lines, 12 input address lines, which is from here, it is clear which are these 12 address lines, starts from input address line 0 to input address line 11. So among these 12 address lines, which of these 2 input address line? Now input address line among these 2 input address lines, 12 address lines, the 2 input address lines which is the 2 input address line, just a minute, 2 input address lines which is input, that is input address line 4 and 3 are connected to the chip select port of this memory blocks through a decoder as shown in the figure. As we know that these 2 input address lines, IA input address line 4 and input address line 3, they are connected to the chip select port. Where is this chip select port? For every block there is chip select, CS, chip select port. For every block there is chip select port, and to select one of this, out of this 4 memory block, to select a block, there is a chip select line. If this chip, and this chip select, here it is written, the chip select is active high. So when this port is high, then for example, for this block, when this chip select port is high, then this block of memory is accessed, and when the chip select port of this block is 1, then second memory block will be accessed. So to select each of the, out of 4 blocks, to select a particular block, we need a 2x4 decoder, which takes input, here takes input A0 A1, where A0 is connected to input address line 3 and A1 is connected to input address line 4. Now these 2 input lines, depending upon this bit combination in this 2 input address lines, that is input address line 3 and 4, one of the output line of this decoder will be activated. So number of output lines in this decoder is 4, which are denoted as Q0, then Q1, then Q2 and Q3. So depending upon the value in this input address line 3 and 4, one of the output line of this decoder will be selected, and when one of the output line is selected, then corresponding memory block will be selected to access that memory, to access that particular block of memory. So if we find out that if the input address line 3 and 4 are used to select a memory block within out of 4 memory blocks, so which 10 of the input address lines are used to address each of the memory location of every block, which of these input lines. So again we go to the so what we have find that these 2 input lines, input address line 3 and 4, that this 2 input address line will be used to select a particular block of memory. Because there are 4 blocks, so we need a 2x4 decoder. Based on the value in this input address line, one of the output line of the decoder, 2x4 decoder, will be activated, and the line which and depending upon the which output line has been activated, then that output line is connected to which of the chip select port of the block, that block of memory will be selected for accessing that memory. So now the question is, as we know, the size of the memory block is 2 to the power 12 bytes. Among them, so number of address lines to address each of the memory location of every block will be 2 to the power 10. So how many bits will be required to access each block of memory? So for every block, that will be 10 bits. So which of these 10 bits out of this 12 address lines will be used to access each of the memory location within a block of memory? So out of these 12-bit address lines from AD0 to AD11, if we exclude the input address line 3 and 4, then the remaining 10 address lines will be used to address each of the memory location for every block. So for any block, any block of memory, this location AD0, AD1, AD3, excluding this input address line 3 and 4, then AD5, address line 6, 7, 8, 9, 10, 11, which can be any bit, maybe 0 or 1. So for every block of memory, this 10 lines will be used. This 10 lines, these and this 10 address lines will be used to access each of the memory location of every block. Now remaining these 2 input address lines, AD3 and AD4, that will be connected to the chip select port of every block, that will be connected to the chip select port of a block through a decoder, so that a particular block of memory can be selected. So if we go back to the question, we can see that now what it has been said here, the remaining here, the question is the remaining 10 input address lines, which is input address line 0 to 11, excluding the input address lines 3 and 4, this remaining 10 input address line are connected to the address port of these blocks. So now if we see the picture, now the input, now the question is that input memory address, which is from input address 0 to 11 in decimal, for the starting address of each block will be from 0, will start from 0, and that is indicated for every for a block is indicated x1, x2, x3, x4. So what will be the starting address of every block? If we take any block, the starting address, so the starting address for every block will be only this bit positions will be 0, starting address for every block of memory, but only this two input address bits, that is address line in address input 3 and 4, this will be varied. This will vary for every block of memory because they are connected through a decoder, and depending upon the values of this, one of the output line of the decoder will be selected, and the output line host which has been enabled, that will select only a particular block of memory. Now we will see that what bit combination of AD input address line 3 and 4 will select which of the memory block. So for that we have to go back to the question, but if we see that starting address, that means the lowest address for every block, that all be 10 address lines, 10 address bits will be 0. Only for now to find out the total input memory address for the starting location of every block, only this 2-bit AD input address line 3 and 4, that will differ. Now we will see that for what values of input address line 3 and 4, which chip will be which block of memory will be selected, and depending on that, if we write these values in here, then it will I will get the starting address for that particular block of memory. So what now here it is what is said in this question, that starting to input memory address, the starting location of each block. The starting location of each block is indicated by x1, x2, x3, x4. So this is a starting location for this block. This is the starting location x1. For this block of memory, this is starting location x2, and for this block of memory, this is starting location is denoted as x3, and for this memory location, the starting location is denoted as x4. Now if we go to now we want to write this input memory address for starting location x1, then input memory address for starting location x2, and the input only this 10 starting location means all of this 10 bits will be 0. So only the 2-bit input address line 3 and 4 will differ based for different for each block of memory out of 4. So this will be the starting location for memory address for starting location x3, and the last starting location will be x4. Now we have to place a proper value of bit position 3 and 4 for each of the starting memory location, where x1, x2, x3, x4, they are the starting location for different 4 blocks of memory. So for that we have to find out this how this 2 input address lines is connected to which of the memory block. Depending on that, the starting location x1 will vary, x1, x2, x3, x4 will vary. So we go back to the question. Now here suppose a decoder A0, A1 is connected to address lines 3 and 4. So when the bit position 3 and 4 is 0 0, then which of the output line among Q0, Q1, Q2, Q3 will be activated? Now depending upon bit combination, if this bit combination of this input address line 3 and 4 is 0 0, then output line Q0 is activated, and this Q0 is connected to which memory block? This memory blocks for which the starting location is X1. So the input memory address is total 12 bits. So input memory address, this 10 bit location for 10 bit address line for starting location will be 0 for every block. Only the bit position for input address line 3 and 4 will vary. Now we are seeing that when this 3 and 4 input lines are 0 0, then output Q0 is enabled. Output Q0 is enabled, which is connected to the chip select port of that block whose starting location is X1. So for X1, what will be the value of input address line 3 and 4? That will be 0 0. So we can write it for X1, the value of this input address line 3 and 4 will be 0 0. Now we will see what will be the value of input address line 3 and 4 for starting location X2. That means another block, starting location of second block. So for that we go to the picture which is showing the memory connection, the connection between memory, the memory connection with the address lines and input address lines. Okay, now see, when the input address line 3 and 4 is equals to 0 1, so then that time this output line Q1 will be enabled, and this Q1 is connected to which block? This block of memory for which the starting location is X2. So for X2 starting location, what will be the value in this input address line 3 and 4? That will be 0 1. So we give back to that value for X2, the bit position 3 and 4, that will be 0 1. That will be 0 1. Now what will be the values for 3 and 4 for starting location X3? So we go back to the connection picture. Now here see that when Q is A0 A1, that means input address line's value equals to 1 0, input address line 4 1 and 3 will be 0, then this output line Q2 will be enabled, and which is connected to this block whose starting location is denoted by X3. So for X3, starting location X3, what will be the bit position for 3 and 4? 3 will be 0 and 4 will be 1. So we write this. For starting location X3, the bit position will be 1 0 for address input line 4 and 3. Now for 4x starting location X4, what will be the value of this two input address lines? So we go back to the picture. Now when this both of these inputs, that is A0 A1, that means input address line 3 and 4 both are 1, then output line Q3 will be enabled, which is connected to this block of memory whose starting location is X4. So for starting location X4, what will be the value for input address lines 3 4? Both will be 1 1. So for starting location X4, the value of address line 3 and 4 will be 1 1. So for starting, this is the starting location of first block, starting location of second block, and starting location of third block, and this is starting location of fourth block. Now for this starting location, what will be the 12-bit input memory address? That we are finding it here. Now we have to represent it into decimal. This, what will be the value of x1, what will be the value if we, for starting location x1, what will be the, then what will be this 12-bit input value of this 12-bit input address line? Now this is will be 0. Now for starting location x2, what will be the value of this 12-bit input address line? That is this is 1 2 4 8 and all are 0, so decimal value will be 8. Similarly, for starting location x3, this will be the input memory address. And what is the decimal representation of this memory address? Now 1 2 4 8 16. So this 16 bit position, that there is one. So starting input memory address for starting location x3 will be 16, and for x4 what will be the this become the input memory address 12 bit. So if we represent it into decimal, it will be 1 2 4, this is 8, and this is 16, that is 16 plus 8. This weight bit position is 1, so 16 plus 8 equals to 24. So for starting location x4, what will be the decimal value of this 12 bit input address line? That will be 24. That we have find out. Now what is the question? Question is asking, so the input, what will be the input memory address which is from input address line 0 to 11 in decimal for the starting location of each block, and the starting location of that block are denoted as x1, x2, x3, x4. So what will be the decimal representation of the input memory address for the starting location x1, x2, x3, x4? We have find out. Now the question is, there are options. Now which one is correct? Which one is correct? So these are the options. These are the options. 0, one of the option is 0 1 2 3, one of the option is 0 1 0 2 4 2 0 4 8, and another option is 0 8 16 24, and the last option is 0 0 0 0. Now among this, what the result we have find out? What would this the value input memory address for starting location x1, x2, x3, x4? We have find out this is 0 8 16 24. So if we go back to the question, is there any option? Yes, this option C is saying the input memory address for starting location x1, x2, x3, x4 is 0 8 16 24. So option C is the correct answer. Okay, thank you.